What is up, guys? In this episode we will go through building the distance from star and habitable zone visual. First we will be checking how to gather the star images and then design the habitable zone area in Figma. And finally how to join everything together with a measure in Power BI. So buckle up and let's get into it. For this visual we will require a base sphere that we can use to display the planet's approximate distance from its star. Then we will be displaying the approximate distance in the AU units, and we will check if the planet is in the estimated habitable zone from the star. So to start with, we can go to Figma and we can create a sphere that we can modify and use as the habitable zone indicator. So here I'm adding some gradients to the sphere, making it a green color, then inputting the middle gradient color as a lighter color with more transparency, and finally displaying the gradients close to each other to get the effect. Next we can export the ellipse and we can add the exported PNG to Figma. Then we can open the 3D transformer widget. If you don't have it already, you can get it from the Figma apps. Now when we open the 3D transformer to the PNG sphere, it will create a 3D version of that ellipse. So now we can modify the ellipse to fit into our distance from star visual. Then we can split the sphere into two so that we can later fit the different star types. And now the base is ready, so we can go and start gathering the different star types. Now in order for us to get the different star types, we can go to Power Query, we can go to the main planets table, and we can add the star type as a new query. Then we can remove the duplicates, so we are left with all the different star types. We can rename the column as star type, and then we can copy it to an Excel file. We can add another column for the AU distance unit, and then we can go and search for the values. So here I just went into Copilot and I asked it to return the habitable zones in AU units for the star types that we have. Here I removed the unknown star type, as we don't really know the values for that one, and the Copilot came up with this list of different values for the star types. So as you can see, all the star types do not have value associated, so some of the types only have approximate distances, such as farther out or very close or extremely close for the dwarf stars. So these are the values we can work with. So now we can copy the values from Copilot and we can go and add them into the star type Excel. Removed the unknown star type. Here I pasted values in our AU column in the Excel file. Now I'm cleaning the values a little bit to make them easier to read. For the O type I just input farther out, the T type very close, and the Y type extremely close. Renaming the sheet as star types, and then we can save the file in our Planet Files directory as star types. Now when we have the values ready, we can go and find the images for the different star types. So we know some estimates what the color of the star is based on its size and age. So now I just went to Google and the T dwarf, and I made a search with the different star types, and I just copied an image for each type. Then renamed the image as the stars type and placed it in our image folder. Now I went back to Figma and I found a nice picture with the 3 different dwarf stars. So from this one I cropped the Y dwarf, as the L was not on the types, renaming the stars as Y type and T type and exporting them to the image files. Next I go back to Pixlr and we can do the same background removal that we did for the different planets. So here I select all the different star type images, paste them into Pixlr, background remover, and then for the images that need some editing I go to the fine tune and create some further edits. When we are happy with how the stars look, we can export them to our image folder, and then we can go back to Figma and place all the different star types here. So now when we have the different star types, I make some final cropping to make them even size. Then I rename all the images as the correct type. And then I select everything and I change the size as 250 times 250 pixels. At this point we can just export all the different star types to our images folder. Next we can start to place the stars inside the habitable zone area. For this one I will place all the different types inside the habitable zone area. Then I copy the ellipse, the habitable zone area, and I place it for each different star type. So for each star type we have the ellipse. Then I group all of the different types so that it becomes a group with the habitable zone area and the star image, and then renaming the group as the stars type. Now when they are ready we can export them to our image folder so that we have the different types as a base for the distance from star visual. So now we can go to the folder where we have all the planet images and we can paste all the star types here. Then we can go back to Power Query to our planet images table and we can refresh so that all the star types also appear here. This way we don't need multiple tables. And now we are ready to create the measure for the habitable zone and the distance from star. To start with, we can create a measure, call it a distance from star. We can create the first variable, planet. Here we can calculate the planet images, where the planet name is the selected planet from the planet table. We can create the second variable, call it star type. Here we calculate the planet image. We can select all from the planets table. Then where the planet from the planet images is the selected star type from the planets. Then we can create the third variable, call it multiplier. So here we calculate the sum of the orbital radius from planets, where the planet is the selected planet. And then we can create the fourth variable, call it planet zone. Here we will define the planet's distance from the star. So we can do switch selected value, and then we can select the star type. And here I go back to our star type Excel file. I copy the different types and paste them into the measure. Now I multi-select everything with Alt and clicking, and then adding the double quotes. First, I create a static value as a placeholder for all the different types. So here I input 1 times the multiplier. Also adding the unknown type star. Next we can return the variables. We can create a CSS style block. Here we can create a new attribute. We can call it container. Below the container we can add position equals relative. Then we can do image1, which will display the habitable zone ellipse we created in Figma and the star image. Here position is absolute. Then the width we can add 280 pixels. The height 170 pixels. Then for the left value 300 pixels. Then top 50 pixels and close the image. Now we can duplicate the image, name it as image2, so this will host the different planets. The position absolute, the width we can input 60 pixels, the height also 60 pixels. Then we can add a right, and here we can input 80 plus the planet zone variable, and then end it with pixels. And the top is the same 50 pixels. And the top we can input 80 pixels. Then we can duplicate the image 1 and image 2, add them below. Then we can remove the values and we can add z index equals 1 for the image 1, as this will be the star and the habitable zone element that is going to be on bottom. And then for the image 2 we can add z index equals 2. This is going to be the planet that moves over the habitable zone. Then we can do end style, and now we can call the container class, div class equals container, then image class equals image1 src, and we can add the star type variable. Now we can duplicate the class, change the image to 2, and we can add the planet variable. End the div with end div, and now we can input the distance from star measure in the distance from star box, and now we can input a HTML visual into the distance from star box. Remove the background, and then we can model it to fit into the box. As you can see, I stretched it a little bit wider so that the planet will fit. We can adjust the planet distance from the star later so that it stays inside the box boundaries. Now I add the orbital radius to a table so that we can test the different values and see how much the planet moves. Next, to the filter panel on the left, I add the star type so that we can change between the different star types. And then we can start to input the values for the planet zone variable and the distance multiplier. So here we can create approximate measurements for the multipliers, and then we can adjust them a little bit later. So for the G-type star, which by the way our own sun also is, I will add if the multiplier is over or equals 0, and if the multiplier is less than 2.7, then we can call 110 times the multiplier, and if the multiplier is over or equals 2.7, add 310, as this is the value where the planet is nearly in the far edge of the box. Then for the K-type star, we can add is over or equals 0 and is less than 3, we can add 220. And then if the same, if is over or equals 2.7, then 310. Then for the F-type star, over or equals 0 and multiplier is less than 0.95. Then we can add 10 times the multiplier, and if it is over or equals 0.95 and it's less than 4, then we can do 70 multiplied by the multiplier, and if the multiplier is over or equals 4, then add the far edge 310. Then for the M-type star, this is the star type where the planet's habitable zone is close. So if the multiplier is over 0 and less than 0.15, then we can call 1000 times the multiplier, and if the multiplier is over or equals 0.15 and the multiplier is under 3, then we can add 550 times the multiplier, and then if it's over or equals 3, we add the far edge. Then for the A-type star, we add if it's over 0 and less than 0.95, then 60 times multiplier, and if it's over or equals 0.95 and less than 12, then 250 times the multiplier, and over or equals 12, then the far edge. Then for the B-type star, we add if the multiplier is more or equals 0 and less than 3, we add 20 times the multiplier, and if it's over or equals 3 and less than 10, 30 times the multiplier. If more or equals 10, we add the far edge, we use the 10. Then for the O-type star, we add if the multiplier is over or equals 0 and the multiplier is less than 0.95, then 60 times the multiplier, and if it's over or equals 0.95 and is less than 6, then 10 times the multiplier, and the same end. Then for the T-type dwarf star, we add if it's over 0 and less than 0.95, then 60 times the multiplier, and if it's over or equals 0.95 and less than 2, then 80 times the multiplier. Over 2, then we add far edge, and then the Y-type dwarf star, we add over 0 and less than 0.1, 1300 times the multiplier, and then we can add the end. Then for the unknown type star, we can just add 250 to place the planet always in the middle of the box, as we don't really know the distance for the habitable zone. Now we can test the different measurements and see how far or close we get with the different type stars and planets for their approximate habitable zones. Now we can go back to the measure. We can add if is filtered. So if the planet name is filtered, then we display the measure and otherwise blank. So the measure will only display when a planet is selected. Now I test the different star types to see the approximate distances from the star. Here the planets orbiting the G-type star look pretty good already. Trying the K planet, we can see that we get the planet out of bounds. So here I go to the measure, and in the K-type star I adjust the multiplier 1.5, under 1.5, and then over 1.5. Now it looks better. Then checking some other planets, they look quite good. So now I move to the next star type. So the O-type, they also look pretty decent. Then the Y-type star looks okay. The T-type, and here in the M-type some are out of bounds. So I go to the M-type star and adjust the multiplier less than 0.5, and if over or equals 0.5. Then the B-type, which is farther away from the star, looks okay. And finally the F-type. Now we can go to Power Query, to the star type table. Then we can import star types Excel, where we have the AU distance for the habitable zone. First row as headers. Then I remove the star type table as we don't need it anymore. Now in the planets table we can merge the star types by star type. Now I extend only the AU unit from the table so that we get the distance measurement. Now renaming the column as Habitable Zone and then moving it next to the star type. Now we can apply. Now we can go back to the report and create a new measure. We can call it orbital radius. This is going to display the different key indicators and values for the distance from star visual. So first create variable radius. So here we select the selected value, the orbital radius, and then concatenate that with orbital radius AU unit. Then create variable habitable. So here we define whether or not the planet is on the habitable zone if selected star type equals G-type star. Then if the selected orbital radius is more or equals 0.95 and the selected orbital radius is less than or equal to 1.37, then we can select yes, it is on the habitable zone, and otherwise no. Then we can duplicate the value. Here I copied the different AU units for each star type as a reference, and the next I define the K-type star. So if it's over or equals 0.38 and is less than equals 0.76, then yes, otherwise no. Then replicating it for the F-type star, more than equals 1.12 and less than 2.24. Then the N-type star, here the habitable zone is very close, so it's more or equals 0.08 and is less than 0.32. Then for the A-type star, here it's further away, so it's more than equals 2 and less or equals 4. Then for the B-type star, it's even still further away, so more than or equals 3 and less or equals 6. We only had estimate that it's further away, so we can input is possibly on the habitable zone or not in the habitable zone. O-type star, same thing, it's even further away because they radiate huge amounts, so is over or equals 6 and is less or equals 12. Then for the T-type dwarf star, this is very close to the star, so it's more or equals 0.05, less than 0.15. Then finally for the Y-type dwarf star, this is the closest, so 0.01 less or equals 0.65. Then we can define a new variable, call it star type, and here we select the selected star type. Then can return first if any planets are filtered. So to display the visual, if a planet is filtered, we can define the CSS style block, input the text color as white and the font size 15 pixels. Then end style, then we can call the style with div class equals style, then add b for bold, orbital radius, and we can return the radius variable, then input spaces, the AMSP, then add the zone habitable, return the variable habitable, line break, return the star type, spaces, and the habitable zone is the selected habitable zone. Then end div, and for the if the planet name is filtered, we can input the else condition as blank, so nothing is displayed if planet is not selected. Then end round bracket, and we can input the orbital radius to new HTML visual. First removing the background, changing the font family, aligning the text to center and align it to the box. Now there are still some planets that don't display quite right, so we can fine-tune the distances to have the planets show correctly in the visual. So here, as you can see, some of the K-type star planets don't fit into the square boundaries. So here I went back to the distance from star measure and changed the value in the K-type star. So it's less than 1.4, then 220 times the multiplier, and if is more or equals 1.4, then the far edge. Now, as you can see, now the planet fits into the box boundaries. And while testing different planets and star types, they seem to fit correctly and display on the habitable zone. So that's it for this episode. We now have half of the visuals ready and the report starts to form. In the next and final episode, we can work on the descriptions and attributes to complete the report. I hope you enjoyed this episode and found it useful. If you have anything on mind, leave a comment below, and like always, don't forget to like and subscribe if you enjoyed the content, and see you in the next one.